Hi, I'm going to present to you about the thread. Thread in operating system. Before I going to present about that, let me introduce our members group. My name is Muhammad Elmi bin India. I am semester 4 I am semester 4 of software engineering. The another member is Muhammad Altaf bin Abdul, also of software engineering. Muhammad Syafiq bin Mazin, Muhammad Afif Amar bin Kamsani, and Ahmad Fazrul bin Saleh. You know what is thread? Thread is a set of CPU utilization. It comprises a thread ID, a program counter, a register set, and a stack. It shares with other threads belonging to the same process its code section, data section, and other operating system resources such as open file and signal. The traditional process has a single of control. If a process has a multiple of control, it can perform more than one task at one time.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Fazrul bin Saleh. My matric number D201101068605. Today I will present about multi-threading model. About our discussion so far has treated threads in a generic sense. However, support for thread may be provided either at the user level for user threads or by the kernel for kernel threads. User threads are supported above the kernel and are managed without kernel support, whereas kernel threads are supported and managed directly by the operating system. Virtually all contemporary operating systems, including Windows, Linux, Mac OS X, and Solaris, support kernel threads. Ultimately, a relationship must exist between user threads and kernel threads. In this section, we look at three common ways of establishing such a relationship, such as the many-to-one model, the one-to-one model, and the many-to-many model. Next, I explain to you about many-to-one model. This is a figure many-to-one model. The many-to-one model makes many user-level threads to one kernel thread. Thread management is done by the thread library in user space, so it is efficient. We discuss thread library in section 4.4. However, the entire process will block if a thread makes a blocking system call. Also, because only one thread can access the kernel at a time, multiple threads are unable to run in parallel or on multi-core system. Green threads, a thread library available for Solaris system and adopted in early version of Java, use the many-to-one model. However, very few systems continue to use the model because of its inability to take advantage of multiple processing cores. Next, we go to the one-to-one model. The one-to-one model is figure the one-to-one model. The one-to-one model maps its user thread to a kernel thread. It provided a more concurrency than the many-to-one model by allowing another thread to run when a thread makes a blocking system call. It also allows multiple threads to run in parallel on multiprocessor. The only drawback to this model is that getting a user thread. because the overhead of creating kernel tree can burden the performance of application. Most implementation of this model restrict the number of trees supported by the system. Linux, along with the family of Windows operating system, implement the one-to-one model. Now we go to the last point. Is many-to-many model. This is figure many-to-many model, and this is a figure two-level model. The many-to-many model multiplexes many user level trees to a smaller or equal number of kernel trees. The number of kernel trees may be specific to either a particular application or a particular machine. An application may be allocated more kernel trees on a multiprocessor than on a single processor. Let's consider the effect of this design on concurrency, whereas the many-to-one model allow the developer to create as many user trees and she wishes. It does not result into concurrency because the kernel can schedule only one tree at the time. The one-to-one model allows greater concurrency, but the developer has to be careful not to create too many trees within an application. And in instance, may be limited in the number of trees she can create. The many-to-many model suffer from neither of these shortcomings. Developer can create as many user trees as necessary, and the corresponding kernel trees can run in parallel on a multiprocessor. Also, when a tree performs a blocking system call, the kernel can schedule another tree for execution. One variation on the many-to-many model still multiplexes many user level tree to a smaller or equal number of kernel tree, but also allows a user tree to be bound to a kernel tree. This variation is sometimes referred to as the two-level model. Two-level model, figure 4.8. The Solaris operating system supports the two-level model in version other than Solaris 9. However, beginning with Solaris 9, this system uses the one-to-one model. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq bin Mazin. Today I would like to talk about multi-core programming. The trend toward multi-core system continues to place pressure on system designer and application programmers to make better use of the multiple computing core. Designer of operating system must write scheduling algorithm that use multiple processing core to allow the parallel execution. That shown in figure 1.1. For application programmers, the challenge is to modify existing programs as well as design new programs that are multi-thread. I show the figure 1.1. Next is 5 areas design challenges in programming for multiple systems. Number 1 is identify tasks. This involves examining application to find areas that can be divided into separate concurrent tasks. Ideally, tasks are independent of one another and those can run in parallel or individual core. Number 2 is balance. While identifying tasks that can run in parallel, programmers must also ensure that the task performed equal work of equal value. In some instance, assistant text may not contribute as much value to the overall process as other tasks. Using a separate execution code to run that task may not be worth the worst. Number 3 is data splitting. Just as applications are divided into separate tasks, the data accessed and manipulated by the task must be divided to run on separate core. Next area is number 4, data dependency. The data accessed by the task must be examined for dependency between two or more tasks. When one task depends on data from another, programmer must ensure that the execution of the task is synchronized to accommodate the data dependency. We examine such strategy in chapter 5, next chapter, after chapter 3. Number 5 is testing and debugging. When a program is running in parallel or multiple core, many different execution paths as possible. Testing and debugging such concurrent program is inherently more difficult than testing and debugging single thread application. The last from my presentation is multi-core programming is because this challenges many software developers argue that the advent of multi-core system require an entirely new approach to designing software systems in the future. Similarly, many computer science educators believe that the software development must be tasked with increased emphasis on parallel programming. That's all from me. Thank you.
Assalamualaikum dan selamat sejahtera. Today I would like to present about chapter 4, thread in operating system. The topic that I picked to present is about thread library. What is a thread library? Thread library is a provide programmer with API for creating and managing thread. There are two primary way of implementing. Firstly, library entirely in user space. Secondly, kernel level library supported by the operating system. We have three main thread library in use today. Firstly, POSIX Bthread. Secondly, Win32, and thirdly is Java. I would like to present about detail about three main thread library in use today. Firstly is POSIX Bthread. POSIX Bthread is may be provided as user level or kernel level. POSIX Thread is a POSIX standard IEEE 1003.1c API for thread creation and synchronization. POSIX Bthread is a API specific behavior of the thread library implementation is up to development of the library. The second main thread library in use today is a Win32. Win32 is a kernel level library on Windows system. Finally, the main thread library in use today is Java. Java is thread managed by the JVM. Java is a typical implemented using thread model provided by underlying operating system. That's all.
Assalamualaikum dan salam sejahtera. My name is Muhammad Rafif Ahmad and I'm going to present about thread pools. In this situation, whenever the server receives a request, it creates a separate thread to service the request. Whereas, creating a separate thread is certainly superior to creating a separate process. A multi-thread server nonetheless has potential problems. The first issue concerns the amount of time required to create the thread, together with the fact that The thread will be discarded once it has complete. The second issue is more troublesome. If we allow all concurrent requests to service in a new thread, we have not placed a bound on the number of threads concurrently active in the system. Unlimited thread could exhaust system resources, such as CPU, time of memory. One solution to this problem is to use a thread pool. The general idea behind the thread pool is to create a number of threads at process startup and place them into a pool where they sit and wait for work. When a server receives a request, it awakes and thread from this pool. If one is available and pass it the request for service, once the thread completes its service, it returns to the pool and awaits more work. If the pool contains no available thread, the server waits until they become free. The thread pool also offers this benefit. The first is servicing a request with an existing thread is faster than waiting to create a thread. The second is a thread pool limits the number of threads that exist at any one point. This is particularly important on systems that cannot support a large number of concurrent threads. The third is separating the task to be performed from the mechanics of creating the task allows us to use different strategies for running the task. For example, the task could be scheduled to execute after a time delay or to execute periodically. The other point is the number of threads in the pool can be set heuristically based on factors such as the number of CPUs in the system, the number of physical memory, and the expected number of concurrent client requests. More sophisticated thread pool architecture can be dynamically adjust the number of threads in the pool according to usage pattern. Such architecture provides the further benefits of having a smaller pool, thereby consuming less memory when the load on the system is low. We discussed one such architecture, Apple's Grand Central. Apple Grand Central Dispatch later in the section. The Windows API provides several functions related to thread pools. Using the thread pools API is similar to creating a thread with the thread create function as described in section. Here, a function that is to run a separate thread is defined. In the other point also, other members in the Windows thread pool API includes activities that invoke function at periodic intervals or when an synchronous input-output request complete. The Java until current package in the Java API provides a thread pool utility as well. Thank you.
Okay, that's all from my group for the presentation. The members group is Fazrul, Shafiq, Altaf, and Amar, and me. And we hope this presentation can give benefit or understanding about chapter 4 in operating system. Thank you for watching this video.